Okay, let's look at 1C. So use your answer from part B to find an estimate of the total amount of water in the tank to the nearest liter at the end of 8 hours. Okay, so we know that, what do we know? We know that WT represents the water is being pumped into the tank and then the water is moved via RT. So we're getting in and we're pumping in so what do we have really here? We have a tank. You're having a certain amount of water that's getting pumped in, and then there's water that's coming out, right? Okay, so when we have these sort of questions, what we have is, going back to our lessons, this is integration applications. We have this formula right here that helps us to solve. And in essence, what we're saying is that if we, anytime you have something dealing with integrals of the rate of change to a given change, you have the accumulation problem, and we can solve it via essentially taking. Sorry about that. We can take the original. Let me move this up. We can take the water that is being pumped in. If we subtract the rate it's leaving, we get what? We get how much water we got left, right? Okay, but you also have to remember that in the initial problem, we started off with 50K liters of water in the tank. So, what are we going to do? Well, we're going to start with the 50K. So we have the 50,000. We're going to, keep in mind, that's RA here, right? What are we going to do? We're going to add to that the integral of the change, right? And the change is that we have WT minus RT, right? DT. What am I saying? I'm saying that what we have going on here, right, is you're getting this water pumped in at a certain rate and it's leaving at another rate. If you subtract the differences between these rates, you get how much water you have left, right, when you integrate, right? The integration of a rate gives you an amount. Again, the integration of a rate gives you the amount. So, we need to know what our bounds are. Well, in the original question, we are going from 0 to 8, right? So the bounds are from 0 to 8. Okay, so what I'm going to do is I'm going to go ahead and separate. So we're going to have 50K still, plus the integration from 0 to 8 WT dt minus the integration from 0 to 8 of RT. RT dt. Okay. Well, what do we know? Well, remember back here we were solving, right? We solved for RT, right? This value here represents RT. So we know this part here is just going to be 80,000. So we have 50,000 plus the integration of 0 to 8 WT dt minus, what was that number? 80/50. 80/50. Okay? So, the next question is, well, that's fantastic. Now, how do I figure out what WT is? Well, remember, WT is given to you in the beginning of the problem. WT is right here, right? So that function is going to be, so we're left with now 50,000 plus the integration of 0 to 8, 2,000 e to the negative t squared over 20 dt minus 80/50. Now keep in mind, you are allowed to use a calculator, so we can type this in the calculator. I'll make a video of how to type that in the calculator as well in a future video. But if we solve this now, we end up getting 50,000 plus this integration right here, is going to be 7836 roughly minus 8050. So if we solve that, we get 49786. Right? And that's our answer. But wait, I forgot to put liters. So we're going to put liters. Okay. I'll see you all in the world of 1D.